video, I'm going to go through looking at working with students on numbers that are factors or numbers that divide into other numbers and so on. So, using a deck of cards again, I've taken one suit of 1 to 10. Here I've chosen spades. I've got another suit and I've just got 1, 2 and 3. In other words, ace being 1. And laying them out in a random order if you like. Again, if you know what you're doing, you can probably... And then of another suit, I've taken ace up to 9 plus the joker, which I'm going to use as 0. So I've laid out the 1, 2, 3 like that. I've laid a pile of the ace to joker, and then the 1 to 10 I'm just going to put down randomly like this and lay it all down. So you take a number from the 1, 2, 3 and take a number anywhere from the pile. I'm going to take the top one. So we've got 24. So then, just a fun way of approaching what is divisible by number goes into 24. So does 10 go into 24? It doesn't. So let's put that aside. 1 goes into 24. Yes, 1 does divide into 24, goes into 24, or is a factor of 24. You can use different language. It's quite important to you to vary your words like that. So then you can ask the student, how many times does it go in? And obviously it goes in 24 times. 3. Is that a factor of 24? Yes, it is. And you might want to talk about the fact for the divisible by 3. You know because you also know because 2 plus 4 is 6, and that is on the 3 times table. And that's one of the factors of it being divisible by 3. And you can say, okay, how many times does 3 go into 24? It goes in 8 times. And you keep going through the cards like that. 6 is a factor of 24, and it goes in 4 times. 9 is not a factor of 24. I'm going to put that to the side. 8 is a factor of 24, and it goes in 3 times. And you might want to start being, okay, 3 times 8 is 24. You might want to put them in pairs like that. 2 is a factor of 24, and you can ask child or student how many times it go in, and it goes in obviously 12 times. If you don't have a card for 12, clearly. 4 is a factor of 24, and it goes in 6 times, so you might want to put those two together. 7 is not a factor of 24, and 5 doesn't go into 24, or you can say 24 is not divisible by 5, so you can put it like that. Okay, I'm going to turn the cards back over like that and lay out these cards back in a random order again, and the ones we didn't use. So just doing it with another thing, I'm going to choose a number here and choose one card from here and put the 4 to the back and just choose top one. So it's going to be 30, that's the 0. So, and then again we go through here. 6 is a factor of 30 and it goes in 5 times. 9 is not a factor of 30. 1 is a factor of 30, it goes in 30 times. 10 is a factor of 30, it goes in 3 times. 2 is a factor of 30 and goes in 15 times. 4 is not a factor of 30. 3 is a factor of 30, goes in 10 times. We can put those two together if you want to. 5 is a factor of 30, goes in 6 times. Put those two together. 7 is clearly not a factor of 30. And finally, 8 is not a factor of 30. Okay, one more go through. So I'm going to put the joker to the back. Turn the 3 over. You can shuffle these cards if you like. So lay these back down. So turn one of these cards over, turn the card here over, and we've got 19. Now clearly 19 is prime. So we know that the only number that will go in of these numbers here will be 1. So if we go through this, and then you can put all of them aside apart from the 1, and then you can also say they don't go into 19, and then you can say, okay, are there any other numbers that go into 19? There clearly are not, apart from 19 itself, and then you can discuss it being prime. Now, a possible extension task on this is to ask if you've got a number like, apart from the 1, let's take 7, okay, you can say how many times does 7 go into 19 and what is the remainder? Or even further than that, so obviously that goes in twice with a remainder of 5. Or you can, if the child really can cope with it, you could say, okay, what is that as a mixed fraction? What is 19 divided by 7? And that's obviously going to be 2 and 5 sevenths. That's obvious to us anyway. And if the child's very good at fractions, hopefully they can do that.